Imagine a subway car made from aluminum alloys, including amenities such as open gangways between cars, mohair-upholstered seats, mirrors, and filtered air, providing a quiet ride on rubber springs and rubber-cushioned wheels. No, not the future. In 1939. Let's step back for a moment to 1929, when the Electric Railway Companies organized the Electric Railway President's Conference Committee, whose goal it was to design a streamlined, comfortable, quiet, and fast accelerating and braking streetcar that would meet the needs of the street railways and appeal to riders. By 1936, such a car had been developed. The first to purchase 100 of these new cars, dubbed PCC cars, was the Brooklyn and Queens Transit Corporation, a subsidiary of the Brooklyn Manhattan Transit Corporation, or BMT. For more information on the history of the company, see my video about the rise and fall of the BMT. I will now read from the BMT press release. For release, Monday, July 11, 1938. Orders for an experimental, streamlined, lightweight, high-speed, three-section car built of aluminum alloy and equipped with rubber-cushioned wheels and rubber springs to materially reduce noise in operation on L and subway lines have been placed by the New York Rapid Transit Corporation, it was announced today, at the BMT offices. This new ultra-modern car is expected to provide an important and far-reaching advance in the design and equipment of cars for L and subway operation, as the modern street cars now operated on the Smith Coney Island, McDonald Vanderbilt, 7th Avenue, and Erie Basin streetcar lines in Brooklyn provided in the street railway field. The major purpose of the new type car is to adapt for rapid transit lines the results of the $1 million research activities jointly financed by leading transit companies of the country that provided the scientific and engineering basis for the design and equipment of the modern streetcar. The car bodies and trucks of the new type rapid transit car will be constructed by the Clark Equipment Company of Battle Creek, Michigan. The motor and control equipment will be furnished by the General Electric Company, the air brake apparatus by the Westinghouse Air Brake Company, and the door operating equipment by the Consolidated Car Heating Company. The car will be 80 feet 4 inches long and of the articulated type, with 4 trucks supporting the 3 sections of the car body, 1 truck at each end of the car, and a truck under each of the 2 vestibules connecting the center and end sections of the car to permit passengers to pass from one section to the other. There will be seats for 84 passengers, and the total passenger capacity of the car is estimated at 318 passengers. The trucks will have rubber springs to support the car body, similar to the rubber springs used with great success on the modern streetcars in Brooklyn, Chicago, Pittsburgh, Baltimore, and other cities since their introduction in Brooklyn in October 1936. The trucks for the rapid transit car will include contact shoes to pick up power from the third rail and automatic stop devices for use in connection with the block signal system used on the rapid transit lines. The use of rubber springs not only helps to improve the riding qualities of the car, but helps to reduce noise in operation by eliminating contacts between metal parts. The use of high-tensile aluminum alloys in the body structure makes possible a substantial reduction in weight as compared to the standard type subway cars. The estimated maximum weight per axle of the new car with full passenger load is 14,400 pounds, as compared with 35,000 pounds for a standard subway car. The estimated weight per linear foot for the new car with passengers is 1,430 pounds, as compared with 2,014 pounds for a standard subway car. The estimated cost per linear foot of the new car in quantity production is approximately $500, as compared with approximately $720 per linear foot for cars for the independent subway. For motive power, there will be 8 motors, of 55 horsepower each, one motor on each axle. The control apparatus has been designed to provide rapid but smooth starts and stops by automatically graduating the increase or decrease of power to the motors. This permits faster schedules of operation for this car in comparison with standard subway cars. An important feature of the new cars is the use of 3 braking systems: a dynamic braking system in which the motors are used to stop as well as start the car, a magnetic track brake, which operate directly on the rails and are located between each pair of wheels, and the air brakes with brake shoes on the wheels. By reducing to a minimum the use of brake shoes in stopping trains, much of the brake shoe and steel dust created by the friction of the brake shoes on the steel wheels will be eliminated, and in the subways, particularly the new type cars, will provide a cleaner and healthier, as well as practically noiseless operation. The use of resilient wheels, wheels in which the axles and steel rims or tires are cushioned by rubber pads or sandwiches, vulcanized to steel plates so the car literally rides or floats on rubber, is also an innovation in rapid transit car design. This type of wheel, however, has stood severe tests in operation on the modern streetcars since October 1936. Many of the precision equipment units developed in recent years are to be used in the new car, notably hypoid gears, shock absorbers, and roller bearings, all of which are designed to reduce or eliminate noise in operation. Mechanical ventilation will be provided, air forced by blowers through ducts to various parts of the car so as to maintain constant circulation of air with an air filter to eliminate dust from the air taken into the ventilation system from outside the car. For illumination, the car will be equipped with non-glare high-intensity lights arranged to provide an even distribution of light throughout the car. And thus ends the press release. The car was nicknamed the Bluebird thanks to its blue and white exterior colors. In a February 8, 1939 editorial entitled "It's Done with Mirrors," the New York Times stated that the Bluebird, quote, "will make each trip to work a delightful adventure, each evening's homeward journey a period of happy relaxation," end quote. If the BMT had come this far by the late 1930s, just imagine how much more they could have done if they had remained in business. Although 50 units were ordered, only 5 were delivered. The city opted to cancel the remainder of the order immediately upon taking over the system on June 1, 1940. Progress, innovation, and experimentation, which was the hallmark of the BMT Corporation, gave way to standardization. The city's attitude could be summarized by the Transit Authority's chief car designer, who, quote, stated that he believed a subway car was a people-moving box that needed no aesthetics to work, end quote. For more on the history of the BMT, check out my other video on the rise and fall of the BMT. I will provide the link in the description below.